Hi and welcome to our today demo, which is about Open Virtual Switch or OVS. So in today's demo, we will be reviewing and learning about the OVS and also about Linux namespaces, or in networking term, how we can create VRFs within the Linux space. So in today's demo, we will be using a host, and within this host, we will be creating two VRFs or Linux namespaces called VRF1 and VRF2. And we will be creating these virtual Ethernet interfaces between our VRFs, and we will create a virtual switch also on the top. And we will connect these virtual Ethernets, the other side of the virtual Ethernets, to this OVS switch. We will configure the OVS switch to do the basic packet forwarding between these two switches, between the two VRFs which we have. And later on, we will also do some testing by enabling and assigning an IP address to its switch virtual interface or the bridge interface. So we will make a layer 3 interface on the OVS on this particular bridge which we are creating. And also we will try to enable spanning tree on this virtual switch and see how the spanning tree operates within the virtual switch. So I have drafted also the list of tasks which we are going to do. So the first step is that we are going to create the two VRFs or namespaces, VRF1 and VRF2. So to start with, I will start making a SSH connection to our host, which is this IP address 192.168.211.55. So let's get the console ready. Okay. All right, so I have the SSH key, so I don't need to provide any password, and I'm root and at this host, which is called OVS. All right, so now the first task is to create these two VRFs or namespaces. So we have a command in Linux called ipnetns, network namespaces. So if I call this command with the argument of list, it shows me the list of available namespaces or those VRFs. So each Linux namespace is a copy of Linux stack, Linux networking stack, and includes a complete isolated like routing table or other networking related task. So I will create a new namespace called IP namespace add VRF1, and we will create another one, VRF2. So if I do the list again, it shows me that, hey, now we got two VRFs, two Linux namespaces available in this system right now. Okay. All right, now our second task is to create these virtual Ethernet pairs. So virtual Ethernet 3 and virtual Ethernet 4, which should be connected to each other. And the other one, which is this one, virtual Ethernet 1 and virtual Ethernet 2. So in beginning, we just create these virtual Ethernets and the link between each other, but we will not assign them to anything right now. So let's create this virtual link. So for command for creating that is IP link add virtual Ethernet 1. And we will say type. So the type of this connection is a virtual Ethernet, and we say peer name is, so virtual Ethernet 1 is connecting to virtual Ethernet 2, virtual Ethernet 2. Okay, so if I just say IP link, now we can see that we got virtual Ethernet 2 and we got virtual Ethernet 1. So virtual Ethernet 2 is connected to virtual Ethernet 1, and we got also virtual Ethernet 1, which is connected to virtual Ethernet 2. So the link is created, and we got two presentation of these two virtual Ethernets, virtual Ethernet 1 and virtual Ethernet 2. Let's create the virtual Ethernet 3 and 4. So we can use the same command. We say create the virtual Ethernet 3 type virtual Ethernet, and the peer name is virtual Ethernet 4. Now if I just do the IP link, now we got all of the virtual Ethernets that we wanted is all created. So virtual Ethernet 2, virtual Ethernet 1, virtual Ethernet 4, and virtual Ethernet 3. So all of them are created and they are here. Okay, so let's go back to our drawing and see. So two virtual VRFs has been created. We created virtual Ethernet ports between virtual Ethernet 1 and virtual Ethernet 2. We have created virtual Ethernet 3 and virtual Ethernet 4 as well, and the link between each other. So that's done. Now we will move the virtual Ethernet 1 to VRF1. So we have already created VRF1. We have already created virtual Ethernet 1. We will now move this virtual Ethernet 1 to the VRF1. So right now virtual Ethernet 1 is sitting inside the default namespace or default VRF. We will move it inside the virtual VRF number 1. To do that, we will use this IP link set virtual Ethernet 1 net space network namespace of VRF1. Now if I run our IP link command, you will see that the virtual Ethernet 1 is disappeared from here. So we have virtual Ethernet 2, we have virtual Ethernet 3, and we have virtual Ethernet 4. So it's not inside. So when I issue the IP link, it shows all the links and interfaces which we got inside the default VRF or default namespace. Since the virtual Ethernet 1 is moved to VRF1, we don't see that anymore. So let's do that for the virtual Ethernet 3 as well. So IP link set virtual Ethernet 3 should go to networking namespace or VRF or VRF2. Now if I do IP link, we just see here we got virtual Ethernet 2 and we have virtual Ethernet 4. So virtual Ethernet 2 and virtual Ethernet 4, they are inside our default namespace or default VRF, and these two other side of these interfaces are inside a different VRF right now. Now to check that, we can use this command to say IP net ns exec. So execute this particular command inside the VRF. So inside VRF1, I want to execute the command IP link. So inside VRF1, we have a loopback interface and we have virtual Ethernet 1. Only these two. And if I do it for VRF2, we will see virtual Ethernet 3. Which we can see that. I can do other commands also. I can do ifconfig, for example, which there is nothing there because the interface is down. Okay, so we have done, we have moved already the interfaces. Now we have to assign the IP addresses to virtual Ethernets in VRF1 and VRF2. So we will assign this IP, the 10.10.10.1 in VRF1 and 10.10.10.2 for the virtual Ethernet 3 inside the VRF2. So for assigning that command, we will use exactly the ifconfig command. So I will say ipnetns execute in VRF1. I want to do the ifconfig 10.10.10.1/24, and we will say up because the interface is down, and we will make sure the interface is up. Oh, sorry, I forgot to add the interface name. So ifconfig for virtual Ethernet 1. Okay. Now to verify that, we can do this. So in VRF1, we issue the ifconfig. So in VRF1, ifconfig says I have virtual Ethernet 1 and the IP address on virtual Ethernet 1 is 10.10.10.1. So that's correct. So here 10.10.10.1, they moved it here. So this is completed. Now let's do the same on the VRF2. So we will say ipnetns execute in vrf2. I want to do ifconfig of virtual ethernet 3, and the IP address should be 10.10.10.2/24, and I want to bring up the interface. So this is also done. To verify that, we will say IP networking namespace execute for me in vrf2 just ifconfig, and here we go, virtual ethernet 2, and we have 10.10.10.2. We can do other commands like, let's say route -n. So inside the vrf2 we have just 10.10.10.0, which is the network address for this, and it's just connected to virtual ethernet 3. However, in my current namespace, I mean in the default vrf where we are now, if I do route -n, I have a default gateway as well. So my current IP address scheme is completely different. It's 192.168.2.1.1. So I have a different routing table. vrf2 has different routing table, and vrf1 also has a different routing table. So we have assigned IP addresses here, and so these two vrfs, I mean these two are completely isolated now. So we will not be able to ping each other. So from vrf1 to vrf2. So to test that, we can say ipnetns execute for me from on vrf1. I want to do a ping to 10.10.10.2, which is not working. So 10.10.10.1 is trying to send some ICMP packets to 10.10.10.2, and it doesn't work because they are not connected to each other, right? There is no connectivity between these two. So this part we haven't done yet. Okay, so now let's continue. Let's go back to our drawing. Okay, so we have assigned the IP addresses. Now we have to create virtual switch 1. So virtual switch 1 is going to be an OVS switch, the OVS switch. So on this host, I have already installed OVS with default configuration within the Ubuntu, and we will use OVS commands to create a virtual switch called vSwitch1. And after that, we will have to assign these two interfaces to our OVS switch. So we will create a virtual switch 1. So virtual switch 1 is like a virtual bridge, or in our networking terms, it can be like you can call it as a VLAN. And we will connect these two interfaces, the virtual ethernet 2 and virtual ethernet 4, to this particular virtual ethernet to virtual switch 1. Let's try to do that now. Now to communicate with OVS, we have OVS. If you just press tab after OVS, we get these few commands which we have. So OVS, we have app control, OFCTL. This is for commands for communicating open flow with OVS. So those commands related to that when our OVS is being connected to an SDN controller. We got data plane controller, we got bug tool, TCP dump can help you just to do some, I think, doing TCP dumps. And we got this virtual switch controller. So we will use the virtual switch controller. So this one, if you run it with show, it shows all the configuration of the current OVS, which currently we don't have much configuration. We just say it just gives the OVS version. Now to create an OVS virtual switch 1, a new switch, we will say add new bridge, and we just give it a name. So virtual switch 1. So OVS virtual switch controller, add a bridge, create a bridge for me called virtual switch 1. Now if I do again the virtual switch controller show, now I'm getting this configuration that, hey, there is a virtual switch 1, and virtual switch 1 has a port called virtual switch 1, and that port is called internal. So for each of these virtual bridges or virtual switches, there is one internal port also being created. So that's like the the port which is connected to the I think to the kernel, probably for the whole virtual bridge or virtual switch. Now our next action is to assign these two interfaces to our virtual switch 1. Now to add that, we can use by the way, you can use just OVS vsctl-help. So it gives us all the commands which you can use. So these are all the bridge commands. So we use the add bridge to create a new bridge or new virtual switch. And now we will use the add port. So we'll use the add port on this specific virtual switch, and we will assign those two interfaces. What was the two interfaces? IP link. Okay, so we got virtual Ethernet 2 and virtual Ethernet 4 that we have to assign to our virtual switch 1. So we will call OVS virtual switch CTL add port on V switch 1. Which port we are going to add? We are going to add virtual Ethernet 2, and also we want to add virtual Ethernet 4. So by doing this command, nothing will happen on my existing connection. So if I do IP link, then nothing has changed here. So still I have virtual Ethernet 2 and virtual Ethernet 4. They are both here. But if we call VOVS virtual switch controller show, now we got more details. So we got additional ports, so port number virtual Ethernet 2 and port number virtual Ethernet 4. So both of them are connected to our virtual switch 1. So this is, very similar to our networking world, where you do, switch port access VLAN, 200, and you create 2 or 3 of the switch ports, assign it to one particular VLAN. Here also we can assign these ports, we can assign these virtual switches to a VLAN ID as well, and we can connect this to a trunk interface as well. But simply we just created this virtual switch like VLAN, and assigned these virtual interfaces here. Okay, now let's try and see if we can ping from switch from VRF1 to VRF2. So I will say IP networking namespace execute for me on VRF1. Do me a ping to 10.10.10.2, which is not working, right? So we have connected the interfaces, we have virtual switch, everything is okay, it should work, right? But it's not working. Now let's see why it's not working. Okay, let's do an ifconfig here. Okay, so those two interfaces are not showing here right now, which is, and we do IP link. Okay, here we go. So our virtual Ethernet 2 is down, and virtual Ethernet 4 also is down. So we never brought up these interfaces. So we have to bring up the virtual Ethernet 2 and virtual Ethernet 4, which are both inside the default VRF. So we just say ipconfig virtual Ethernet 2 up and ifconfig virtual Ethernet 4 up. Okay, now if I do ifconfig, now we get virtual Ethernet 2 and 4 because now they are both up and running. They don't have any IP address because they are just layer 2 interfaces, right? They are layer 2 interfaces which are connected to our virtual switch 1, right? Now let's try to do the same command. We will tell IP networking namespace execute on VRF1 ping 10.00 10.10.10.2, which is working. So we brought up our interfaces. Now the communication is happening. So we got everything ready. Let's get back to our drawing here. So we assigned the Ethernet 2 and Ethernet 4. Okay, now we are planning for enabling the spanning tree also between switch 1 and switch 2, and we have to assign IP address to switch virtual interface. Okay, so we will be assigning, let's do this one first. We create a switch virtual interface on the OVS itself with 10.10.10.3. So here we got an interface called virtual switch 1. This is the bridge interface or the SVI interface or IP interface. You know, there we have lots of different acronyms or names for our virtual our virtual interface names, right? You know, different vendors, they call it different things. So let's do that. So we say ifconfig. So for virtual switch 1, I want to assign 10.10.10.3/24 up. Actually, it's already up. If I do ipconfig again, now we got this IP address on this switch, right? Now from here, because we have this IP address on this switch, on the switch interface, I should be able to ping from here, from the default VRF into this VRF and this VRF, right? Because we have direct connectivity and this is the switch virtual interface, right? So if I ping 10.10.10.1, it is pinging. Yes, that's absolutely right. And if I do 2, also that is also pinging. Absolutely right. So now let's go for playing with the spanning tree on the virtual switch here. Let's do our enabling, check if we have a spanning tree or we don't have a spanning tree. Let's see what's going on there. Okay, now, so we call OVS virtual switch controller. Say set bridge, which bridge the virtual switch 1, and STP spanning tree underscore enable equal to true. Okay, now for checking that, you can use OVS DB client. Sorry, OVS DB client, OVS database client, just dump it. Let me make this, maximize this. Okay, so here it gives us some information about the switch. So one of the tables here, open vSwitch table, so port table. So in the port table, we got information about the spanning tree of the ports. So these 2 ports, this is virtual Ethernet 2. Virtual Ethernet 2 is in forwarding state, and virtual Ethernet 4 also is in forwarding state now. So spanning tree has been enabled. So we could run this command actually before that. We can disable it. So false. And we run the OVSDB again. So we don't have any more information about the spanning tree here. If I enable it again and we do the dump, oh, here we go. Now we got the ports are in the listening states, right? So they start listening and then they go into the forwarding if they don't receive any BPDUs. They are still in listening. So if I do a ping now, 10.10.10.1, it's not working because the port is in listening. Spanning tree is not allowing any packets to be received by the port. Once the port is changed from listening to forwarding state, then it will start working. Here we go. So the port started working. If I do the client dump, now the port is forwarding and we have everything running, right? One more thing we can check is how we can find the MAC address table of this virtual switch, right? So this virtual switch which we got here, we should be able to find the MAC address of the VRF1 and the MAC address in the VRF2. I mean the virtual interface in each. We should be able to find that. To do that, we will call OVS application app control. So app control will help us to talk to the OVS daemons, different daemons, and get some information. So if we call OVS app control with the parameters of FDB, forwarding database, /show for vSwitch 1. So here we go, we got 2 of them. right? So this is the local. This one is local, means this should be our virtual switch virtual interface, and this is the port 1, which I'm assuming is for the port 1, the one connected to the VRF one. Now if I ping again the 2, that's also working, and now we got one more here, because you know it has the age. So once there is no packets going to being generated or going to this particular MAC, it will get deleted from the MAC address table. So we got both the MAC address. We can verify that if we do, if you say IP networking namespace inside execute for me in VRF, let's say 2, I want to do if config. The MAC address ends with 8C98, which is matching here. So 8C98, 8C98, that's the same thing, right? So this was our demo about you know, OVS and the Linux networking namespaces or VRFs, that you know you could see how easily we can create virtual switches within Linux, and even you know if you have time, you can build these labs and you can connect also a physical interface also connected to your virtual switch, a specific trunk interface, one of the VLANs of your you know trunk interface. You can connect it to this particular virtual switch, and you can provide full connectivity to this virtual to this VRFs or namespaces inside your host. So this concept you can extend and apply into many things. So instead of these very basic VRFs which we created, you can have virtual machines, of course. So virtual machine or containers, they can be assigned to specific virtual interfaces, and they can be connected to an OVS switch, and you can do you know connectivity between those virtual machine, within the virtual machine, within the host only, or you can connect them to the outside world. So these hypervisors, for example, you know, hypervisor, they can either they use proprietary kind of this virtual switching stuff. Some of them they use OVS, some of them they use just the Linux bridge. And so also, you know, what we achieved today just now with OVS, we could do the same also with Linux bridge. So if we could create a Linux bridge and we could assign these two interfaces to a Linux bridge and achieve exactly the same thing. So OVS and Linux bridge are similar. There are some differentiators that you know I have explained in the course. I think you already know that. But in general, you know, you can create virtual machines. You can add virtual machines or containers or virtual firewall or virtual router, all connected to you know this complex or very scalable OVS, and you can create different scenarios for your requirements. Now, one more thing I want to add here is that if you remember, we were using Mininet, which is a tool for you know testing the SDN controllers. So Mininet also uses exactly the same concept. It uses OVS and it uses Linux namespaces for creating those virtual hosts. But the way they use the namespaces is a nameless method for creating the namespaces. So here we created the namespace with a specific name like VRF1 or VRF2. But in Mininet, when the script actually creates those namespaces for the host, it uses a nameless method. So with a nameless namespaces, you will not be able to see them when the IPnet ns list command has been executed. You will not be able to see those namespaces. So that's the a little bit different when Mininet creates those namespaces. This was all about the OVS and namespaces. I hope it was useful, and please, if you have any question regarding the OVS, you can please write it in the forum or you can contact me directly. Thank you very much.